This question says, find the inverse function of fx equals square root of 4x take 3 and sketch both functions on the same graph. Okay, to find an inverse function, we need to swap x and y. But there is no y here, so I'm going to say let y equals square root of 4x take 3. So you can't just bring a y in from nowhere unless you say let. That's a good way to set it out. Now we'll swap x and y. And we make y the subject. So square both sides and add the 3 and divide by the 4. That's our inverse function, but it's still got the y in it. I'll put it back in terms of fx. So therefore, the inverse function of fx is x squared over 4 plus 3 over 4. Now we need to sketch the graph of both of them on the same graph. So before we sketch, we need to check whether there are any points of intersection. To find points of intersection, normally we would equate one equation with the other. So we try and solve square root of 4x take 3 equals this. But the algebra for that will get too hard, far too hard. So with our knowledge of inverse functions, knowing that they always cause reflections in the line y equals x, if they cross each other at all, it must be on the line y equals x. So it's a lot easier to pick one of the functions, and it doesn't even matter which one, and solve it with y equals x. Okay, this is a lot easier. Square both sides. It's a quadratic, so bring all terms to the same side. Factorise. And solve. Okay, so we found 2 points of intersection. X is 1, x is 3. We need the y values as well, but because they both lie on the line y equals x, then it's got to be 1, 1 and 3, 3. So therefore, the points of intersection are 1, 1 and 3, 3. Now we'll draw the graph. So to sketch this, I think it will be easier to start with the inverse function because I can more easily picture the shape of a quadratic than a square root. So it's x squared over 4, that means it's a bit wider than usual, plus 3 quarters. So here's the point 3 quarters. And it's a quadratic that goes like that. Okay, now I haven't got room on the graph for the negative side of it, but that's deliberate and you'll see why in a minute. So with my points of intersection at 1, 1 and 3, 3, I just need to make sure that it goes through both of those. Okay, now the square root graph is the original function. It's the inverse of this. So if the y value here is 3 quarters, the x-intercept must be 3 quarters for the inverse. So that's at 3 quarters as well. And it will go like that, which does look like the shape of a square root graph. Now the reason I knew that the quadratic didn't go out to the left-hand side at all is because we were told that this is the positive square root. So it's only going upwards, not downwards, okay? And if we are to reflect in the line y equals x, that means only the right-hand side of the parabola makes sense and matches that. So you do need to think carefully about what domain and range you're using And there'll quite often be a clue in the question to help you make that decision. Right, so this is y equals fx, and this one is y equals inverse function. And we should label our points of intersection. And I've already labelled the intercepts. So you know the kind of details that you should be including.